Good day everyone, and welcome to where we are putting together solutions to those math and science topics that we are getting problems with. This video looks at trigonometry of right-angled triangles and the CSEC Mathematics past paper questions from May 2009 to 2014. Feel free to like the video and add any comments down below so we can help you in any math or science area at both the CSEC and the KEEP level. Let's look at the topics in CSEC Mathematics, and we can see there's a list of up to 10. Topics are from 1 to 9, and number 10, investigation, is a combination of any couple topics from above. We will be looking in this video at specifically number 8, geometry and trigonometry. It is a huge topic in CSEC Mathematics as it is worth 8 marks out of 60 in paper 1, the multiple choice, and 21 marks out of 100 in paper 2. Geometry and trigonometry can be subdivided into geometry by itself and trigonometry, of course. And trigonometry itself can be subdivided into two parts. The first being about right-angled triangles, and the second about all other triangles. Right-angled triangles, as we can see from the diagram, there is an angle, let's assume theta, and the longest side is called h, or the hypotenuse, which is opposite the right angle. The side touching the angle theta or next to is called the adjacent side, or A, and the side opposite to it is O. From this relationship, we can find our first formula in this topic, which is Pythagoras' theorem, which relates the lengths of all three sides, such that O squared plus A squared is equal to H squared. And there are three trigonometric ratios that relates the sides, two of the sides and the angle. The first being sine theta is equal to opposite over hypotenuse. Cosine theta or cos theta is equal to adjacent over hypotenuse. And tan theta is equal to opposite over adjacent. There are a couple acronyms that are used to memorize these, including OHEL, another hour of arithmetic, or SOHCAHTOA, whichever is easier for you. During the analysis from May 2009 to 2014, we found that this topic came in the years 2011, 12, 13, and 14. We've made some steps for students who are getting problems in this topic. And the first being that when we are looking at this question, we list all the formulae, which are 4 in this case, and then identify which shape is relevant from the diagram that is given. We draw only that shape, and then identify which sides and angles the question uses. Select the formula, then substitute accordingly into it, and solve for the unknown. These steps will help for students who are getting major problems. A 2011 number 5b, the question, the diagram below, not drawn to scale, shows triangle PQR, which represents a cross-section of a roof. QS is perpendicular to PSR, meaning that they are 90 degrees to each other. PQ is equal to 12.6 meters. QR is equal to 8.4 meters. And angle QPR, which means the angle at the corner P, is equal to 15 degrees. Using the dimensions shown on the diagram, calculate correct the three significant figures. Part 1. The length of QS. Now, in doing our solutions, first of all, if we are getting problems with it, let's write out the formulae that are connected for such a topic: the Pythagoras theorem and SOHCAHTOA, sine theta, cos theta, and tan theta. Now, let's extract the triangle that is required. So we're looking at the triangle on the left-hand side, QPS, where we know 12.6 is QP and the angle is 15 degrees. And we're interested in QS. As such, We're interested in O, the opposite, H, and we have an angle. So this question uses two sides, O and H, and one angle. So when we look at our formulas, the formula which has an angle and those two sides is sine theta. So we now substitute into it. Sine 15 is equal to O over 12.6. Now we want to find O alone on the right hand side. So let's block off 12.6 with our hand. And we write what we have. Sine 15 is equal to O. The 12.6, we now have to deal with it. It was on the right hand side in the denominator or dividing. So when we carry it across on the left hand side, it will end up multiplying. So it will be 12.6 sine 15 is equal to O. Let's use our calculators. This will give us 3.261 is equal to O, which is QS. But we want our answer to three significant figures. So after the third significant figure, which is 6, we look at the next number, which is a 1. And that is a small number causing 6 to remain as is. So our final answer is 3.26 meters. As we continue with part 2 of the question, let's include in the diagram 3.26 meters for QS. Now part 2 asks us to measure the angle RQS. So if we extract that triangle and put in the information we know for the angle that we're looking for, that's the angle in the middle letter, the angle at Q. We know 3.26 and 8.4. 3.26 will be the adjacent and 8.4 will be the longest side, which is the hypotenuse. As such, this question uses two sides, A and H, and one angle. So looking at our trig formula, we can see that formula will be cos theta is equal to adjacent over hypotenuse. Now we substitute into the formula and we get cos theta is equal to 3.26 over 8.4. And now we need to solve for theta, which means we need to have theta alone on the left hand side. So let's cover it off with our hand, the cos, and we write what we have. Theta is equal to 3.26 over 8.4, and let's carry the cos across. And when we carry the cos on the other side, it will be cos inverse. Using our calculators, we can solve for this. Theta is the angle RQS, and that will give us 67.163 degrees. However, let's recall that the answer required is in three significant figures. So angle RQS is equal to 67.2 degrees. Part 3 of the question, we are required to calculate the area of the triangle PQR, the entire triangle. So let's first work out the angle at Q, the angle PQS. So let's extract that triangle, the one on the left hand side, and we know the angle at P is 15 degrees and the angle at S is 90. So P plus Q plus S is equal to 180 because all three angles in a triangle add up to 180. So let's substitute 15 degrees plus angle Q plus 90 degrees is equal to 180 degrees. So Q is equal to 180. Let's carry across the others on the right hand side. So it will be 180 minus 90 minus 15. And that works out to be 75 degrees. So let's look at the entire triangle now. On the left hand side, the angle PQS is 75 degrees. And let's recall from B part 2 that the angle on the right hand side, RQS, is equal to 67.2 degrees. As such, the entire angle PQR is equal to 75 plus 67.2, and that gives us 142.2 degrees. And we want our answer to three significant figures. So angle PQR is equal to 142 degrees. Now the formula that required to find the area of a triangle is given in our formula sheet, and that is A is equal to half AB sine C. And let's substitute into that. A is equal to half times 12.6, which is PQ, 8.4, which is QR, and sine of that entire angle at Q, which is 142. By solving, we'll get A is equal to 32.435, but let's round it off to three significant figures. So that will give us 32.4 meters squared. May 2012, number 3B. The diagram below, not drawn to scale, shows the journey of a ship started at a port P, sailed 15 kilometers due south to port Q, and then a further 20 kilometers due west to port R. So if we look at this question, it is a bearings question, and it works at 90 degrees. As such, this falls under the area of trigonometry, dealing with right angle triangles. So part 1 asks, copy the diagram and label it to show the points Q and R, and the distances 20 kilometers and 15 kilometers. As such, we can label them. We're starting at P, and if we head south to the next point, that is Q, and we head west 20 kilometers, that will carry us to R. Part 2 says, calculate PR, the shortest distance of the ship from the port where the journey started. So let's extract this and put in a red line showing us the distance from P to R. As such, we have a right angle triangle. And let's recall the shortest distance in this triangle from P to R is the hypotenuse of the triangle. And the information we know the opposite and adjacents are 15 and 20 kilometers respectively, and we want to find PR, which is H, the hypotenuse. Thus, this question uses three sides, O, A, and H. So we're going to use Pythagoras theorem. So the formula is equal to O squared plus A squared is equal to H squared. Now we substitute into it. O and A are 15 squared and 20 squared. That will give us 225 plus 400, and that works out to be 625 is equal to H squared. So H is equal to square root of 625. Thus, 25 kilometers is equal to H, which is the shortest distance from P to R. Part 3 asks us to calculate the measure of the angle QPR to the nearest degree. So let's extract the shape and put in the hypotenuse, and that will give us a right angle triangle. And the angle that we're interested in is the angle at the center of QPR, which is the angle at P, which is the angle up on top. Now we know 20 kilometers, so that will be the opposite. And we know 15 kilometers, that will be the adjacent. And let's recall that O and A depends on which angle we're interested in. Since this question uses two sides, O and A, and we're one angle, that means the formula is tan theta is equal to O over A, opposite over adjacent. Now that we've written the formula, we must substitute. So we substitute into there, so tan theta is equal to 20 over 15, and finally we solve. So if you want theta alone, let's cover off the tan. So we have theta is equal to 20 over 15, and move the tan from the left-hand side across to the right-hand side. So when it moves across, it's now tan inverse of 20 over 15. And using our calculators, that will give us 53.13 degrees. But this question required that we do it to the nearest degree. So the angle QPR is equal to 53 degrees. 3b. In the diagram below, not drawn to scale, AEC and ADB are straight lines. Angle ABC is equal to angle ADE, which is equal to 90 degrees. And angle AC is equal to 10 meters, and angle AB is equal to 8 meters, and DB is equal to 3.2 meters. Part 1, calculate the length of BC. So let's now extract that triangle with BC in it, which is the larger triangle. So if we draw over the triangle ABC, what they're asking us to find is BC. And what do we know? We know 10 meters, which is the longest side, H, and we know 8 meters. As such, this question uses all three sides, O, A, and H. So we now have to pick which formula to use. And that formula will be Pythagoras theorem, where O squared plus A squared is equal to H squared. Let's substitute into there, and we get O squared plus 8 squared is equal to 10 squared. Now, when we're ready to solve, let's block off the 8 with our hand, so we can see O squared is equal to 10 squared. And the 8 squared is on the left hand side, it's adding. When I carry it across, we do the additive inverse, or we can say we subtract. So 10 squared minus 8 squared. 10 squared is equal to 100, minus 8 squared is equal to 64. So 100 minus 64 is equal to 36. O squared is equal to 36. So O, which is the side BC, which is what is required, is equal to the square root of 36, which is equal to 6 meters. In part 2, explain why triangles ABC and ADE are similar triangles. So let's look at the solution. If we extract the smaller triangle, triangle ADE, and we extract the larger triangle, triangle ABC, what can we tell? We can tell that both triangles have the same angles, but different lengths. Since all three angles are the same in both triangles, then these two triangles are similar. If the sides were also the same, then they would be congruent. Part 3 asks us to determine the length of DE. So let's extract the first triangle, and in that triangle there, a triangle ABC, what do we know? We know that the right hand side is equal to 6 meters, which we just recalled from B part 1. And we know the base AB is equal to 8 meters. So if we look at the angle A, tan of that angle, tan A is equal to O over A, opposite over adjacent, which is equal to 6 over 8. Similarly, if we extract the smaller triangle, let's redraw that, ADE, and we find tan A, it's the same as above, then tan A is opposite over adjacent. And what is our opposite? DE, which is unknown, and A, our adjacent, is AB, which is 4.8. As such, let's recall that both of them, the angles are the same, so let's write a formula now. Tan A is equal to opposite over adjacent for triangle ABC, and also opposite over adjacent for triangle ADE. So let's substitute. From above, for the first triangle ABC, tan A is equal to 6 over 8, and for the second triangle DE, that will be equal to DE over 4.8. So let's now substitute. Let's block off the 4.8. So we rewrite what we have. 6 over 8 is equal to DE. Now the 4.8 is in the denominator, or dividing. So when I carry it across, it will multiply. So we'll get 6 over 8 times 4.8. And using our calculators, we can solve, and DE will be 3.6 meters. In May 2014, number 3B, the diagram below, not drawn to scale, shows the positions of two ships P and Q at anchor. So P and Q are fixed in the water, and the diagram shows us it's 118 meters apart. And of course, it's not drawn to scale, so we can't use our rulers to measure any of the distances or protractors to measure any angle. They won't be accurate. This is just a sketch. And FT is the vertical face of a cliff jutting out of the water. So FT, according to the diagram, is 80 meters high, and they're giving us right angle triangles. So part 1, determine the angle of elevation of T from P. So in our solution, the first thing to do is look at extracting that triangle, or FTP. It's a right angle triangle, and we want to find the angle of elevation of T. Look vertically upwards from a horizontal position. So how much did our eyes turn? Our eyes turned an angle of 40 degrees. So that is our angle of elevation. In part 2, the length of FP. So let's solve that by extracting the triangle and redrawing it. And if we redraw it, look at where 40 degrees is at the corner of P, which means that our cliff face, TF, which is 80 meters high, is our opposite, and we want to find FP, the adjacent. So we're interested in O and A, and we have one angle. As such, the formula will be tan theta is equal to O over A, and if we substitute, tan 40 is equal to 80 over A. So we can carry the a across. The a is in the denominator, it's dividing. When I carry it across, so multiply. So we get a tan 40 is equal to 80. Now if we want to find a alone, that's where we're going to solve. Then we need to cover the tan 40 with our hands and rewrite what we have. A is equal to 80. Tan 40 is multiplying on the left side. When I carry it on the right, it will divide. It will be in the denominator. So A is equal to 80 over tan 40, and A is FP, which is what we want to find, and that gives us 95.3 meters. And that's our solution. In part 3 of the question, they're asking us to find the angle of elevation of T from Q. Now let's extract it and look at the information that's required. As we redraw the triangle, we can see that we know the opposite, which is TF, that is 80 meters. However, we are unaware of the adjacent, which is the full length FQ. Well, let's recall, to get the full length FQ, that will be equal to FP, that part, plus PQ, the other part. So FQ is equal to 95.3, which we've worked out before in part 2 of the question, right? And then we also know PQ is equal to 118 meters, which they gave us. As such, a total length FQ is equal to 213.3 meters. So this question uses two sides, O and A, and one angle. So the formula we're going to use will be tan theta is equal to O over A. And if we substitute, tan theta is equal to 80, which is our opposite, over 213.3. And if we want to solve for theta, let's block off the tan with our hand. So, and we write what we have. Theta is equal to 80 over 213.3. And now, let's remove the hand, and we have to move the tan. Tan goes across onto the right-hand side of the equation, gives us tan inverse. So, using our calculator, make sure it's set in degrees. We find our angle of elevation of T from Q, which is equal to 20.6 degrees. We've now come to the end of the first video in this series, which is past paper questions on trigonometry, and specifically the right angle triangles from the year May 2009 to 2014. Our next video will be from the years 2015 to 2021.